Chapter 3 is a fairly short but important chapter, and we're going to learn how to solve systems of linear equations, and what we're going to get to is the last section, which is the big one, which is solving applications where I have multivariable linear systems. Alright, so 3.1 really should be a review, something that you've seen somewhere more than once in your algebra history, in your math history. Alright, so solving a system of two equations with two unknowns, two variables, that's linear. Alright, so linear cases meaning I just simply have variables. There's variables, they're not being cubed, squared, they're just simply the variables, maybe times a constant. And so this is the standard form for that two variable case, where it's just a number times x, a number times y might equal another number. Again, a, b, and c are just numbers. X is a simple variable, y is a simple variable. And so an example would be something like 2x minus y equals 5. A solution to a linear equation with two unknowns is an ordered pair, meaning there's an x solution paired with a y solution. It's specific. There's an x value paired with a specific y value. Alright, and again, it's the entire pair that makes the solution true. I have to have the x with the y to make the solution true. Alright, well, how many solutions does this equation have? Can you think of a few? Well, the easiest one for me would probably be 2 and negative 1, right? If I plug 2 in, that gives me 4. The negative 1 gives me a 1. And so that's another one. Or 0, negative 5 is another one. Alright, but there are many, many different ones. If I did 3, 1, right, that's another one, because that would give me 6 minus 1. And I could keep going. Those are the easiest cases. And so how many solutions are there? Well, that's why we graph these, right? The graph comes out, a line is the graph. And that line represents all the solutions. Well, all the solutions, where we draw a line with arrows at the end, so there are infinitely many solutions. Now, there are points, so there's an x paired with y, so there are infinitely many x and y values paired together that when I plug them into this equation, it makes them true. All right, but again, I have to have a specific x paired with a specific y. But there are infinitely many of them. Again, that's why when we draw the line, we can't list the infinitely many cases, but I can draw the line to represent the infinitely many cases. What we're going to get to in this section is a system of two linear equations with two unknowns. And then we are going to eventually do three unknowns, but that's towards, that'll be in the next section. We'll introduce that when we introduce a method to solve them. Alright, so systems right now, we're going to start with two linear equations with two unknowns, meaning I have an x and a y, and that's it. In order to solve a linear system, I have to have if I have two unknowns, I have to have two equations. I have to have as many equations as I have unknowns. If I have three unknowns, I'd have three equations. If I had four unknowns, I'd have to have four equations. And what we want to do when we solve a linear system means more than one equation, is I have to find all of the ordered pairs, all of the x and y values, that make both of the equations true at the same time. So what x and y that are paired together, when I plug it into the first equation, it's equal 3, and I plug it into the second equation, it equals negative 5, right, if they exist. And so this is a much harder case, right? It's much harder to look at it and see, well, can I figure out what numbers add to 3, and when I subtract, I get 5? All right, well, that's much harder to do. It's much harder to figure out. It's also harder to figure out how many solutions. There are actually 3 possibilities. All right, we're going to get to this. So again, this is much harder to do. So we're going to come up with process. And as it turns out, there's actually 4 ways to solve systems of linear equations. 3 of them you should be fairly familiar with, and we're going to introduce a 4th one in the next section. Alright, well, there's 3 possible things that can happen when I have a system of two linear equations with two unknowns. The most common case is this first one, where I get one solution. So I have one pair, one x, y paired together, that makes both equations true. Right? And what happens here is what's happening graphically. This is the case where the lines intersect exactly once. And at that place where they intersect, right, there'd be two lines and they intersect at a single moment. Well, that would be the moment they share, right? That's the point that makes both of them true. And that's the only point that makes this one solution. There's one point on both lines. There's one x value paired with a y value that make both of them true. And that's the most common case. And when we get to applications, that will be the only case we have. But there are two special cases that we will look at in the first few sections before we get to applications, because they can still happen and they're perfectly fine answers, but they are special cases. Right, the first special case is the no solution case, meaning there are no points that are shared by both equations. This case, the lines never intersect, and graphically they are parallel. Right, meaning they never, ever intersect. All right, that's one possibility, and it's perfectly fine. And no solution is a perfectly fine answer in mathematics. Then there's the last case, and the last case is just hardest for students to kind of wrap their head around. The last special case is the infinitely many case. And basically, you start with two different equations, but they solve for the same solution set. So what they do is both equations solve for the same solution set, which is infinite, right? All lines have infinitely many solutions. So if both lines have the same solution set, they share the infinitely many points. And so basically when you graph them graphically, they are the same line, right? Same solution. Again, you start off with two different equations, but when you get down to the nitty-gritty and you go graph them, they're basically the same equation, right? They solve for the same solution set. They have all the same points in common. And so the general solution would be, well, they're infinitely many. Well, how do I write? And that's what makes this one harder. Right? We always want to write a way to get to my solutions, right? And so if I have infinitely many of them, there should be a formula that will generate all of the solutions, the infinitely many solutions. So it is an equation where all I have to do is pick out a single number and I can find a solution to the system, right? Any real number value can be selected since they're infinitely many. So I can pick any of my infinitely many real number values and find a solution. Now, the catch is it's specific, right? There's a specific x value paired with a specific y value. And that's why it's the formula case. And that one makes this one a little tougher. And we'll look at an example. We'll look at one example in this set of notes, and we'll do a whole bunch of examples in 3.2 since this is the harder case. All right, so one solution, no solution, or infinitely many solutions. Well, how do we solve for these? There are three methods that you should have learned in an algebra class. Three methods. We're going to focus on the first method because it's going to emulate what we're going to do in section 2.3 when I introduce a fourth method. But there are two other ones, and I'm going to show you the graphical method because it's a good check one. And then there's a last method which actually your book doesn't talk about, but it's a perfectly good method, and if you want to use it, you can. All right, but like I said, the first method is the one we're going to focus on. The first method is called the elimination method or the addition method. It's also called in some book. It's the algebraic way where you combine, you add the two equations in such a way to eliminate one of the variables. All right, and again, the reason why we're going to focus on this method is because it's going to emulate the process that we will use and learn in the next section, 3.2, which is the matrix method. Right, and so what you do is I want to add my two equations so that one of the variables disappears. It's eliminated. Right, that's why it's also known as the addition method. So elimination method, addition method. Now, so this is the same set I had on the previous page, where I said, is it easy to see what values do I add to get 3 and subtract to get 5? Well, it's hard to answer. All right, but this is actually a simple case to use the elimination method. The elimination method basically boils down to, I want to make sure one of my variables is the opposite of the other. Well, I've already set it up that way. If you look at the y variable is positive 1y in the first equation, and a negative 1y in the second equation. And so my y's are already opposite of each other. And so once that's set up, then all you do is, then you add the two equations. Remember, when you add, you can only add like things. So that's why we set it up, x values first, y values second, equal to the constants. I can only add x values together, I can only add y values together, and I can only add constants together. And so when I add this up, I get an x plus an x. Well, that's going to give me out 2x. This zeroes out, right? It's 0y. That's gone. Because the 1 and the negative 1 zero out. And so 0, that's going to zero away. And then I get 3 plus 5, which is 8. So again, it really boils down to then a simple equation, 2x equals 8. And so I've eliminated the y variable. Right? I've gotten, by adding the two, and I'm allowed to do that. I can add and subtract equations as long as I'm careful with add and subtract. And now it's just a simple equation I solve for x. So solving this equation for x, I divide by 2, so I get x is 4. Now that's not the entire solution. Remember, that's half of the solution. To get the entire solution, I have to find the y that's paired with 4. And so what you have to do is, I have to plug 4 into one of these two equations. I'll pick the first equation. So I'm going to pick x plus y equals 3. I'm going to plug 4 in for my x, so I get 4 plus y equals 3, and solve for my y. And so y equals negative 1. And so my solution is the one solution case. Is the single point, where x is 4, y is negative 1. And you can check that this does work. If I add 4 and negative 1, I get 3, right? 4 plus a negative 1 gives me out 3. And if I subtract them with x value first, so 4 minus a negative 1, right? Because 4 minus a negative really is a positive, it does equal 5. And so they do check, right? And so that is and then that's the only one. Those are the only numbers that are paired together that if I add them, I get 3, and if I subtract them, I get 5. And I have to subtract x from y. Or sorry, y from x. Take x and subtract y. And that's it. That is the only solution that makes both of those true. I add to get 3 and I subtract to get 5. There isn't another pair out there that'll work that way. Alright, so there's the one solution that solves my system. And like I said, this is the most common case. And when we get to applications in section 3.3, this will be the only case that we have. But I am going to look at some special cases in this section. But before we get there, remember I said there were 3 methods. This is the method we're going to look at the most in this section. But there are 2 other perfectly fine methods that you should have learned in algebra. The second method is a good way to always check your answers. The graphical method, right? They're both lines. You can graph them in your calculator. And we want to find where they intersect. That satisfies both equations where they intersect. Alright, and so what we want to do is, we'll graph both lines. In order to graph both lines in your graphing calculator, you always have to have it set equal to y equals mx plus b. That's the only way you can graph them, because if you go look at your graphing calculator, it's set y equal, it's going to, in your calculator, you've got y equal 1, y2 equal, and so on. And so when we plug them in, we always have to plug them into it in that form. And so what first thing we have to do is solve both equations for y. Alright, so solve both equations for y. And so I've got to go back up and find my equations. X plus y equals 3 and x minus y equals 5. So this one's not too bad. I just move x over, and so y equals negative x plus 3. There's one equation I can type in, so negative x plus 3. And then this one will take me a little more work. I've got negative in front of my y, and so I've got to get rid of that negative. And don't forget, you divide everything by a negative 1. And so y equals positive x minus 5. And so there's the second equation that you'll plug into the calculator. Alright, so you plug, and a standard window should work just fine. Let's see if I can get to my calculator. My other program ran out.